You're coding in React using JavaScript. At first glance, your code looks great, so you save the file that you're working in to look at your web app. The problem is the page is completely blank. Because you've been working with JavaScript for a while, you realize that this is probably due to an error. So you open up the console and read through some errors that probably don't make a lot of sense to you. You spend 30 minutes fixing this problem just to have the page completely blank out again. Except this time there is no error and your page is just completely blank. Wouldn't it be nice if there was a way to avoid these problems before runtime? Wouldn't it be nice if there was a way to catch errors during development to avoid a bunch of these annoying JavaScript quirks and make your life much easier? TypeScript is the modern language for developing React apps, particularly for larger apps or apps that are developed by a team. It can make your life as a developer much easier. TypeScript has become the standard, so much so that many tools like Vite, Next, React Native, etc. all generally lean towards TypeScript as a default over JavaScript. And in this video, I'm going to show you how to use TypeScript with React. First things first, it's important to mention that TypeScript is a superset of JavaScript, which means it is JavaScript with some added features. So no, you don't have to actually learn a whole new language. Learning TypeScript comes down to writing JavaScript with some extra stuff sprinkled in. With that being said, before we get into the React specific stuff, let me quickly go over some TypeScript basics so you can follow along. One of the most important things about TypeScript is that it does static typing, which just means that when a variable is initialized, it gets a type when it's compiled, and should always stay as that type. For example, if in this TypeScript file I say let x equals 0, and then under it I put x equals hello, we are going to get an error that says type string is not assignable to type number, because once it's a number, it should always stay a number. If we hover over x here, it says that x is a number. How does it determine this? Because it's being initialized to 0, the TypeScript compiler determines that x should always be a number. This is called implicit typing and means unless you say otherwise, the variable will get assigned the type of whatever value you assigned it. 0 is a number, which means x should always be a number. In TypeScript, if you want to be explicit and write the type yourself, you can add a colon after the variable name and then write the type, in this case, number. It's not necessary in this case since this is very basic and TypeScript can implicitly infer that it should be a number. But if you wanted to be explicit, this is how you would do it. If I replace this number with something else, let's say string, you'll notice how we get an error here because it says we're trying to assign a string to the numeric value of 0. Pretty self-explanatory. The only time I'd recommend being explicit when declaring a variable and not just relying on implicit typing would be if you're not initializing it with a value. For example, if I were to just declare a variable x and I just said let x. If I just write let x like this, TypeScript has no idea what type this is going to eventually be, so it defaults to any, which is generally not a good idea because you're bypassing type safety. If I'm declaring x like this and I know later it's going to be a boolean, I should write boolean after this. That way TypeScript knows what it will eventually be. TypeScript will require you to do this explicit typing in a unique case whenever you're defining arguments for a function. For example, let's say I have a function called doSomething and it takes in 3 parameters, x, y, and z. Notice how we're going to get an error on every single one of these arguments saying that they're all of type any, which again is not very safe in TypeScript. Let's say I want to type these parameters as a number, a string, and a boolean. We can do it just like I showed you before. We can say I want x to be a number, we want y to be a string, and we want z to be a boolean. What this does is allows us to be safe with our parameters. For example, x is a number, so if I were to try and call x dot to lowercase like this, which is a string method, it's going to say, wait a minute, you can't do that because x is a number. Keep in mind, if I were to do this in regular JavaScript, it would not catch this and it would throw an error and potentially crash the app. But because we're using TypeScript, it tells us beforehand that this is a problem that we should address. So we can't call a string method on a number. As another example, if I try to call y.toFixed, just like this, it said we can't do this with a string, but if I do it with x, a number, now it's fine. Because toFixed is a number method, not a string method. If I try to assign any of these parameters to something different than its type, like I try and say y equals true, it's going to say, nope, y should not be a boolean, it is a string. Hopefully with these examples, you get the picture. One thing you might be wondering, we've used numbers, strings, and booleans so far, so primitive data types. But what about when you want to work with an object? After all, using objects is extremely common in JavaScript, so how do we handle these in TypeScript? To handle objects, we generally need to make a TypeScript type that has the outline of the object we're wanting. For example, let's say in my code I am going to have, let's say, a user object in here. we will just call this user object, and we'll go ahead and delete this. Maybe this user object will be pulled from an API or something that has 3 properties: name, age, and isAdmin. We can make a type to define all these things. So how we do that is generally, we would do it outside of components, which I'll go over in a bit, but we can write type, and then whatever we want the type name to be, I would call this user equals, and then curly brackets. So we would write this very similarly to how we write an object. Except instead of filling it in like a normal object, we'd write the object property, then a colon, and then the type of this property. So for example, if we had a name property, we would want to write the type of this as the value. So we would say string. If we had age, we would want to say number. And if we had isAdmin, we would want to put that as a Boolean. So writing types in TypeScript is very similar to objects in regular JavaScript, but for our values, we're focusing on the data type. Now, since we've made our own type, we can use this type as we would any other primitive types when declaring a variable. So if in our function called do something, we hover over this user object, it says it has type any, so we need to give it some type. Well, we can do it just like we did with the primitive types. We can give this a type and say we want it to be of type user, referring to the type that we made up here. And if we hover over it, you can see it references that type. This is how we're always going to deal with objects the clean way in TypeScript. Define what you want the object to look like with a TypeScript type, and then assign the variable to that type if it's supposed to be that object. One quick thing to mention up here when making types is that we can make certain properties in this object type optional. For example, if we didn't want to require the isAdmin property, we could add a question mark before the colon here, and this tells TypeScript that it's perfectly okay if we don't have an isAdmin property, but if we do, it should be a Boolean. Apart from objects, another very common non-primitive type that you may see is arrays. Arrays are very simple in TypeScript. If I want a variable to be an array, I need to define the type of values in that array followed by square brackets. For example, in this function here, let's say I just have another argument x, and I want x to be an array of strings. So I could write x, I want it to be strings, but I want it to be an array of strings, so I now add square brackets to show that it's an array. Now, if I go in this function body and I try to do something like change an index 1 to be an integer, it's going to say, wait a minute, this isn't right. This should be an array of strings, not of numbers. But if I try and change it to something like YouTube, now the error goes away because this is a string, just as we typed it up here. Now that you understand how basic typing works in TypeScript, we're going to talk about 2 more quick things before we get into the React specific stuff: unions and intersections. Sometimes it may be necessary to accept multiple types for a single variable. For example, let's go back to our user object, even though we're not using it right now. Let's say, for example, we want age to be either a number or a string. How do we do this? All we need to do is write the union operator, which is a straight vertical line, and then whatever other type we want it to be. So let's say we want age to be a number or a string, so we can say number or string, and that's what that would read as. And note that this OR operator is the same OR operator that you would use in most languages in any conditional statement, so it's easy to remember. Anywhere where you want to expect multiple possible types, use a union. You can add as many as you want. So I don't know why you'd want to do this, but if I wanted this to also be a Boolean, I could say or it can be a Boolean as well. So we can say age is a number, or a string, or a Boolean, and it will be happy if it is any of these 3. You can do this with primitive data types, or you could even do it with type aliases for objects like user or arrays or whatever else you wanted. So this wouldn't make sense because we're defining it in itself, but let's say I wanted this to also be possible to be a user type. We could define user as well in here as a possible type. You could also use unions if you wanted to make an array that could support more than just one data type. For example, this array right now only accepts an array of strings, but we could add parentheses right here. And we could say we want it to be strings or numbers and do closing parentheses, and this would be valid TypeScript. So now this array could be any string or any number. So having an index change to YouTube is fine, and also having it change to a number is fine as well, because both number and string are acceptable. If we tried to do a Boolean, however, like true, now we get an error because that is not one of the possible types that we specified with the union. So that's unions, pretty straightforward. Next is intersections. I'm not going to get too in-depth about intersections, but they are essentially ways of extending types. For example, let's say we need 2 types of users, ones that are admins and ones that are not. We already have this isAdmin, which is great, but let's say admin users require their own separate admin ID. We could make admin ID an optional property, Or what we could do is make another type for admin users called userAdmin. So I can go down here, I can say type userAdmin equals this. I could write user and, which is the symbol for intersection, and then now write the type as we normally would. In this case, I would just add admin ID, which I would want to be a string. What this intersection right here does is gives us access to all of the properties of user and the type we specified after. So if we were to give a variable the type of userAdmin, it would have all these fields here, name, age, and is admin, and it would also have this admin ID. So we're basically combining user with this type, and that's what an intersection is. So just like normal and or, unions and intersections are sort of opposites. Union, meaning or, means a value can be of this type or of this type. Intersection, meaning and, means a value will have properties of both types, in this case user and this userAdmin type. I think we've gone over enough general TypeScript stuff. With that being said, let's move on to the React-specific applications of TypeScript. One of the most important aspects of incorporating TypeScript into React is being able to add types to the props of any given component. A big issue with vanilla JavaScript is that when you're creating your props in React, whether you're destructuring or keeping it in a props object, the component has zero way of knowing what data type the props are until they're passed in. So for example, in this card component, if I have a prop that is called text, your code has no way of knowing what type this text could be, and TypeScript can't implicitly just guess that. We as humans can see that it's called text and probably infer that it's going to be a string, so we should tell that to the TypeScript compiler. And before we write anything, notice that if we're using TypeScript, this will highlight as an error. That is because in React, TypeScript requires you to type your props just as it requires you to type regular function parameters like I showed you a moment ago. Now, it'd be nice if we could just write text and then type it string just like this in the props argument. But as you can see, this still draws an error from TypeScript because this isn't the correct syntax. There's essentially two different ways we can handle typing our React props. The first way would be to add the props keyword in front of this destructured object. So we would do props and then like this. And then you can individually type each property like we've done here with text, making it a string. This works just fine, but the issue with this approach is that to access the props now, like text, we'd have to write props.text instead of just text. The whole point of props destructuring is avoiding having to use the props keyword everywhere, so I don't typically go with this approach. The way that I like to handle typing props is creating a type for them. Typically what I would do is go above the component, so I'd go up here, and I would create a type. I would say type, and then I would name it the name of the component and then props after that. So in this case, I would call it card props, just like this. And now we would set the types of our properties. We only have one prop to worry about right now, that's text. So we'd say text, and we would type it as a string. And let's say I want another prop to account for in this card component, one called count. I could say count, and that would be a number. And now we'd want to make sure in our props here that we have it matching exactly as we have it in the type up here. So we're expecting a text prop, and we're also expecting a count prop. How do we tell the props that it should be expecting this type that we defined up here? It's super simple. All we need to do is go after the closing curly bracket here, add a colon, and then write the name of the type. In our case, it is card props. Now, this card component knows that its props should consist of text, which is a string, and then count, which is a number. Where this comes in handy now is when we actually render this component and pass in props. In our app.tsx file here, let's have the card imported that we just created, and if we try and render it down here, notice how it has a red underline, and it says that we are missing our properties, text and count. So it's letting us know that we have text and count defined here in the properties, but we're not actually passing them here, hence why it gives us this error. To silence this, we could, let's say, pass in our text prop, and let's give it a property of, we'll just say hello. And notice if we hover over it, it still says that we are missing the count. So now let's pass in count. Except for count, I want to intentionally pass in the wrong type. Count should be a number, but I'm going to make it a string. I'm going to pass in and say that this is high. Now it's giving us an error on count here, and it says type string is not assignable to type number. So to correct this error, all we need to do is pass in something that matches the type that we defined in the card props, which is a number. So let's pass in 0, and now the error is silenced. This is a really nice feature of TypeScript in React, and it avoids unnecessary errors that JavaScript would not catch in our React components. I'll give you an example of how this could save us from an error. Imagine in our card component, we tried to, in the function body here, we tried to call count.to lowercase. In TypeScript, it shows us an error here and says, wait a minute, the to lowercase method can't be used on a number. But in vanilla JavaScript, if we were to do this, the page would just straight up crash before giving us any warning, and we'd have to check the console to find this error. Now, this is a super simple example that might not happen in real code, but this can certainly happen on accident in scenarios more complex than this one, and that's why TypeScript enforcing prop types is very important. Let me give you another scenario. Let's say in app, we want to render multiple card components, so let's render in 2 more of these same cards. However, for the sake of our example, let's say these 2 most recent cards that we just rendered don't actually need a count prop, they should just have a text prop. So let's remove these from the properties. We're still going to get an error saying that we're missing the count prop, but we don't even want a count prop on these 2 cards. How do we work around that? Super simple. In our card component, we can choose to make the count prop optional by adding the question mark as I showed you earlier. If we do this now, we go ahead and save this, and we go back to the app, notice that the error has been silenced. The question mark signals to the compiler that it is perfectly acceptable if we don't have a count prop passed into this component. So we're saying this card doesn't need a count prop, but if it does have one, it needs to be a number. This basic prop typing works for the majority of cases, but what about cases where what we're passing in isn't a primitive type, or even a simple object or array? For instance, what if we're using the children prop in a component? We know that children is a reserved keyword in React, but without adding any types here, TypeScript is going to show us that this is a problem. What could we possibly type children as? Is it a basic type? Is it a JSX element? What is it? And how do we type it? Well, the way we can typically type children is by making the type react.reactNode. So to show you this, I'll alter our card props here and have an argument called children and make it react.reactNode spelled just like this. And then, just like before, I will give this the type of card props. But what actually is react.reactNode? If we hover over it here, it gives us a basic description of what it actually means. It can be a string, number, boolean, or essentially any other React element. It says down here that it's basically anything that can be rendered within React. The reason why we generally type children as React node is because to invoke the children keyword, we need to pass something in between the opening and closing tag of the component in question. In this case, we have just passed hi, so the string hi, and actually I don't need the quotes here, hi would be the children of the card component. And we could pass in a lot of things here. It could be hi, it could be blah blah blah, it could be a JavaScript expression, it could be a string, boolean, number, or it could even be another component. If I had a component called like box, for instance, we could have that component rendered in here as well. That's why we type it as React node, because that's all possible options of things that we could render in React. And notice how if we do nothing here, let's say we empty this out, and children isn't being passed in right here, then it's actually completely fine with that, and there's no error shown. That's because if there's nothing passed in right here, then children will just be undefined. However, if I actually remove the closing tag here, and I just do a self-closing component, now we're going to get an error saying that we're missing the children props. That's because now children isn't undefined, it's just straight up missing. So if we want to do children, we need to make sure we always have an opening tag and a closing tag, or else TypeScript is going to show you that it's a problem. Because again, having undefined children is fine, but having missing children is not fine. What about a situation where I need to type a React setter function? For example, let's say an app I have state that is called count with a setter function of setCount. Sometimes it's necessary to allow the child component to alter the state of its parent, in which case we could pass in the setCount as a prop, and we'll just pass down that setCount setter function. If we do this, how do we type setCount in the component that is receiving the props? In this component, I already have the code set up to call this setCount prop to just increment the count by 1 each time it is clicked. But up here, where we're setting our type, what do we put for the type of this particular function? Well, lucky for us, if we go back to app and hover over setCount here, it actually tells us exactly what the type actually is. It is this whole thing right here. So what we can do is we could go and copy it, and we could go into our card, paste it, and we would paste this as the type here. And this is actually going to be the type of all React setter functions that are using useState. You'll just need to make sure this type inside here matches the type that you're working with on the particular state in question. In this case, it's a number, so we have number in this type. This whole thing looks like a lot, but just know that if you need to know the type, you don't have to memorize it. You can just go to whatever setter function you have, hover over it in VS Code, and it'll tell you exactly what the type is, and you can just copy and paste that into here. Having this whole thing right here as our type makes it so that setCount can only be a React setter function. It can't be a general function, it can't be any primitive, it has to be a React setter function, which helps keep it as strict as possible. Speaking of functions, how do we type functions in general? For example, in app, let's say I have a function that is called alertMessage that takes in one argument message that will be a string, and it just alerts whatever that message is. I want our child component, in this case card, to be able to call this, so I pass it down as a prop. How do we now in the card component actually type this function? It's actually pretty simple. We just need to give a general function skeleton by writing the parameters and their types, plus the type of return. So for example, our alertMessage function has one argument message. That should be a string, so we can write parentheses, message, and that should be a string, and then we would write an arrow like we're going to write an arrow function, and then we can add the type that is being returned from this function. This particular function doesn't have a return statement, so that means that it will return nothing or an otherwise void. If it did return something, like let's say we had something in here that just returned message, then we would want to specify that this return value should be a string, not void. But in our case, we can just keep it as void because we're not wanting to actually return anything. This is the format you're always going to follow when you're typing functions. Parentheses with the arguments and their type, followed by an arrow, followed by the type of whatever is being returned. If it's nothing being returned, then you can say void. Next, let's talk about how to deal with objects as props. This is realistically going to be one of the more common use cases of prop typing. So let's say in app we have 3 user objects in this users array right here. Maybe theoretically we could have pulled this data from an API somewhere. Then I'm mapping over this users array, and for each user all I'm doing is returning a card and passing that user down as a prop. This is something that if you've used React, you've probably done a lot. And real quick, it's important to mention here that when using a map statement, that making a user parameter right here doesn't actually need to be explicitly typed. Why is that? Well, when you use certain methods like map or for each, TypeScript is intelligent enough to know that you're referring to a singular instance of whatever you're mapping over. In our case, it's each one of these user objects. So long story short, you don't need to be explicit when you're doing a map statement. However, the real question is, how do we type user as a prop in the child component that it's being passed down to? Because after all, we need to type it up here in the card props. Typically, how we would handle this in React is by extracting the object type into its own type, like I showed you earlier. So above this, I could just write, actually I'll do it above the component, but below this type, I'll make another type that I'm going to call user. And then in here, specify the fields that the user should have. We know it needs name and age, so let's do name as a string, followed by age as a number. Now up here in our card props, what type should user be? Well, it should be this user type that we just created. So we can say user just like this. Now everything should be running smoothly. We can look for any errors that TypeScript is throwing. It looks like it's not showing anything, so we should be good to go. This is generally always how I handle objects as props. Have the props always as its own type if you have particular objects. In this instance, we have this user type that matches the users that we're getting from, some mock API. And you just want to make sure that these types match accordingly. So in this case, name should be a string and age should be a number. In a large application, you might not have all the types for particular objects like user in this file. What many people do, especially if they need to reuse the same type over and over again, is just make a folder in source called types, and then define types within a file there and export them, and then just import them into whichever file they need. Since our app is tiny and used for just examples, we don't need that, but that's something that you could keep in mind. Earlier, I showed you how to use unions for types, and I think unions can come in handy in a couple of different scenarios in React. One of the ways I like to use unions is for styling stuff with Tailwind. For example, let's say for my props for this card component, all I want is a color prop, and that should be a string. But we only want it to be very particular strings. Let's say for this color prop, we only want to accept 3 colors, red, blue, or purple. We can create a union and say the string red, or the string blue, or the string purple. By doing this, we limit color to only one of these 3 strings. Here, I've just added a color map object to map the 3 possible colors to static Tailwind classes. And then in the JSX, I can access that particular Tailwind class by accessing that particular color we got for our prop. If I go into the app and now specify a color prop, I can specify any of the particular colors. I could say color is blue, and that would work just fine. I could do red, and that's also fine, or I can do purple. However, if I try and do something like, let's say, green, I'm going to get an error here saying that green is not one of the 3 possible options between red, blue, and purple. So hopefully this makes sense how we're limiting it to only these possible options by using the union for our props here. We could do this with any number of CSS properties that aren't just background color with Tailwind. For example, I just added here another size prop that only accepts 3 possible strings: small, medium, or large. And we have a similar mapping, size map down here that works kind of in the same way. And in our class name, we've specified that same size map like this. If we now go into our app, we know that we are expecting a size prop, so we can specify size, and then we can pass in any one of the possible strings. We can do small, which is fine, medium, or large. But if I, for example, try and do something that we haven't accepted, like XL for extra large, we're going to get a problem here saying type XL is not assignable to small, medium, or large. So it makes sense. So we're limiting it to any of those strings. So let's say medium, and you can see there's no problem. Hopefully you get the picture. Union types can be really nice when working with Tailwind, and it's one unique case and use case for unions. One of the more common use cases of TypeScript in React is typing the useState hook. I showed you a moment ago how we might type the useState setter function when we're passing it down as props to a child. But what about the actual state itself? Let's imagine we have a piece of state here called count with a setter function of setCount that is just initialized to 0, and we're just printing it out down here in our JSX. If we hover over count right here, it says the type of count should be number, and that is another example of implicit typing. Because we put 0 right here as our default value, TypeScript can infer that count should always be a number. But what if you wanted to manually type count to a number? The way we could do this is by going after our useState here, but before the parentheses, and typing in angled brackets in the same way we would type them in JSX. And then in here you can specify the type. In our case, we would want this to be a number. In this case, doing this is totally unnecessary because having 0 as a number is easily implied. But one scenario where it might be necessary is when dealing with API data, when you're fetching some information asynchronously. For example, instead of having count, let's say I have a userstate here that just has a type of user, which refers to this type up here. It has a name, which should be a string, and age, which should be a number. With TypeScript, it's generally not a good idea to leave this useState empty. And that's because if you leave the parentheses empty here, this state, in our case user, will be undefined, as you can see right here. And TypeScript won't be able to check the validity of this type right when this state is initialized. Just so you know exactly what's happening, I'd say it's generally a good idea to put this here as null, especially when dealing with asynchronous data. That way, if the object is null, you know the data has not been loaded in yet. But wait, now notice that we're getting an error right here. And that's because we just told TypeScript that we're wanting this to be a user type, and yet we have just initialized it to null, so we've just contradicted ourselves. The way we generally handle this is by doing a union type and saying this can be a user type or null. And that's because if this is async data from an API, it really has 2 possibilities on what it can be. Null if it's not loaded in yet, and a user object if it is loaded in. We have to account for both scenarios, because if it is asynchronous, it will be null right when the page first renders, and user once it actually fully loads. Not handling one of these scenarios properly might lead to errors. Because user can be either user or null, we need to be careful of how we access it in the JSX down here. Doing something like json.stringify user is fine, but notice if we do something like try to access a particular property, in our case let's say name, we're going to get a TypeScript error here and it's going to say user is possibly a null. And that's completely valid because if the data isn't loaded in yet, it will be null, and trying to access a property of null will have an error thrown. If you're familiar with data fetching in React, you've probably seen this error before, cannot read properties from null or cannot read properties of undefined. If we, however, go in front of this period here and we add a question mark, notice how the error goes away. And this question mark tells our code that, hey, it's fine if the name property doesn't exist on the user because it could possibly be null. It means that user.name will only be shown in the JSX if user is not null. I, however, don't like having to add a question mark to every single object property, because I just find it annoying and it can lead to problems down the road. The way I like to handle this generally is having a piece of loading state, like we have right here, that is a boolean either true or false. That starts as true and gets set to false once the data is loaded in. And then in our JSX, we can check if loading is false, and then only if it is, then we can display properties of the object because we now know that the object is no longer null. If we look, however, we can see that TypeScript gives us an error here, saying that user might be null still. Unfortunately, TypeScript isn't quite smart enough to deduce that actually it can't be null with this conditional right here, because with this use effect, if loading is false, that means in this particular case, that user cannot be null. This isn't a huge problem in the long run, however, and we can get around this by just adding another conditional down here. We can just add user like this, and that will actually silence the error. So before we try and access a property of user, we're also just making sure that user itself exists, because if it is null, this will not be true, and it will not even try to access this. I still like to keep this piece of loading state here so I can do things like display a loading icon, but in terms of silencing this TypeScript error, we'll need to add the object in question to the conditional statement to ensure that TypeScript is satisfied. So we're saying if loading is false and the user object is not null, then we can go ahead and display the user.name. Hopefully that makes sense. Another thing you should absolutely know how to do with TypeScript is type events in React. For example, on click, on change, on submit, or any other event that is commonly used. So let's imagine I have a button down here in our JSX that just says click me, and whenever it's clicked, it calls a function called handleClick and passes in that click event. We know this handleClick function is expecting the e argument up here, but if we hover over this, it says it has any type. How do we know what the type of this event actually is? Just like we did earlier when hovering over the useState setter function, we can also hover over the event object in our JSX right here, and it tells us exactly what it is. For example, in our case, it is this right here, react.mouseEvent, HTML button element, and mouse event. So we can actually just copy that, add it as a type here, and then paste it in. And keep in mind, this type right here is going to change depending on what type of event it actually is. On change and on submit would look different than this one. But you can always hover over the argument right here to figure out what the type of it should actually be. No need to try and memorize these things. As another example, if we had an onChange event right here where we're calling it for a text input field, we can just hover over this e argument. It will tell us it is this react.change event, if I can get it here, react.change event like this. So we can copy that, and that's how we can type our event in our handle change function. This will always remain the same for event handling. Look at the e argument in whatever event you're talking about. It will tell you what the type is, so that's how you can type it up here in whatever handler function that you have. If you've worked with JavaScript objects and arrays before, you know that even if you declare a, for example, array as being const, you can still actually change the values in the array. So I could still say numbers at index 1 equals 5, and this wouldn't be a problem because I can still mutate and change the numbers inside of this array. If you want to truly make an object or array read-only, TypeScript has a feature called asConst that you can add after the declaration of that variable. So for example, for this array here, I can say equals 1, 2, 3 asConst, just like this, and now it will throw us an error here saying that we cannot assign this index because it is a read-only property. The same exact rule applies for objects. If I have my object here that just has one property, age, that is set to 46, and I make it asConst, if I try and modify that like I am down here, it's going to say we can't change the age because it is a read-only property. So asConst is something you can use with arrays and objects to make sure it is actually a true constant. And this is introduced with TypeScript. Another common hook you may want to type is useRef. Refs are pretty simple in TypeScript. If we have a button, for instance, that needs a ref attached to it, and we're declaring the ref right up here with the useRef hook, and you want to type this ref, all we need to do is hover over this ref down here in our button, and let's look at what it tells us the type is. Well, we can see here it is this HTML button element. So we can actually copy that, and we can do an angled bracket similar to how we did with useState, and we can put that as our type for this ref. This is just another one of those types that kind of just depends on what you're using. So for button, it is HTML button element, but if I were to change this to something different, like let's say I made it a span instead of a button, I could go span like this, and now if I hover over the ref, it'll say HTML span element. So we can just take that and we can replace that here, and so now we're referencing a span element. So essentially it just depends on what the ref is actually referring to, and that will determine the type that you can type it up here. I generally don't get too caught up in ref types, but if you wanted to do it, that's how you would. The next topic I want to talk about is generic functions. Generics are a fairly common thing in many other programming languages, but JavaScript does not natively support them. However, TypeScript does. A generic function is one that can work with multiple data types instead of just one. To show you this, here I've set up my own custom hook called useFetch. And its purpose is to be able to fetch any data given a URL from some, let's just say, some mock API. So it's expecting the URL argument as a string, and then here it has a useEffect hook where it just will go ahead and fetch that data from that URL, set the data, and then it will return that. So it's pretty straightforward, just a way to fetch data from some API link. The issue right now is that we don't have anything typed. For example, we don't have this useState typed here. We don't have any function return typed, because the fact is we don't know what's actually going to be returned from this right now. Could the data be an object? Maybe it could be a string. Maybe it's just a Boolean. We don't know because we're fetching data that we're assuming, for the sake of this example, we don't know the type of. We don't necessarily need to know, but it might be a good idea to keep things type safe. The way that we can type this simply is by using something called generics. To use a generic in whichever function is in question, in our case the useFetch function, you can go here before the arguments of the function, add angled brackets like we've been doing, and you can put T right here, which stands for type. It doesn't actually have to be T, you can name it whatever you wanted, but T is standard practice. What this T is here is almost like an argument. It will catch the type of whatever is passed into it. For example, if I wanted to call this hook an app, I could write something like const data equals useFetch, and then pass in just some string right here. Let's just say blah, blah, blah. And I want to make sure that's imported as well. So I can just import useFetch up here at the top. If we added angled brackets on this useFetch call, and we passed in some data type here, let's say string, then now what this will do is if we go into our useFetch hook, on this particular call right here, T is going to be equal to string, because that is the type that we're passing in on this particular call. What you might be asking is, why would you want to pass in a specific type to this hook when right now it would theoretically work just fine? Well, typically you'd want to pass in a type in order to specify what you want the return value of the function to be. So in this case, in this function, we are returning data. The thing is, we don't know what type data is without using this T here. To specify the return value of a particular function when you're working with generics, you can just add a colon after the parentheses here for the arguments, and you can just write the type of the return that you want. In this case, it would be of type T, or let's just say it could also be of type null. Because after all, if this response didn't go through, it might be null, so we're saying returning null is fine, or returning T is fine. So if we're passing in a string right here, then we're saying useFetch is going to take in this string, and it can return a string or null. We could also now use this T here when typing the useState hook. If I'm passing in T as a string, like this, then that would mean I would expect data here to be a string. So we will say data here will adapt to whatever type that we're passing into it. And for here, in this, we need to say T or null, like we did before, because we're accepting null as a possible value. And because T represents the type of data that we're actually fetching from this mock API, we could technically take it one step farther. If we hovered over this JSON data right here, it's going to say that it is of type any. Well, technically, it is of type T, because this will represent any possible type that we pass in, which could represent the JSON data itself. Adding this T here for this JSON data type simply adds a slightly higher level of safety in terms of making sure that the data is of the correct type, and does not just have type any. Where this is going to become useful is if we're trying to fetch different object types from an API. For example, let's say back in app here, we have two types. We have user, that is just name, which is a string, and age, that's a number. And then we have another type called blog post that has title, description, and posted, which should be a date. They are both their own unique types, and these are two possible object types that could be returned from our theoretical API call with useFetch. So to get a user from useFetch, we could do something like const user equals useFetched, and for this one, for the type, we want to make sure it is of type user. If we wanted to get a blog post from this useFetch, we could do kind of a similar thing. We could say const blog post here equals useFetch, and it should be of type blog post. Because again, this is what we're expecting to be returned from the useFetch, and it's how we're making sure that the data is typed correctly. So in summary, adding the generic T type here in our useFetch allows us to specify the types whenever we call said function like we are in app right here. You may be wondering, couldn't I just remove this typing in app? Like, couldn't I just delete this and then delete this and then not even worry about this T at all, and it would still technically work just fine? And the answer is yes, you could. But if you want to ensure maximum type safety, then I'd recommend using generics and explicitly writing out the type when you call a function, especially if the function's going to have different return types each possible call, depending on how you're using it. If you've gotten more into the intermediate and advanced side of React, you're probably familiar with the React context library, where you can use create context and use context to pass down information through components without prop drilling. I have the basic skeleton here set up to handle this situation. The first step to working with context is always to call the create context function to create the context that we're talking about, which we have right here, and we're initializing it to null. Similarly to how we use angled brackets for other hooks, we can do the same thing here. But right now we know that null is one of the possible types, so let's at least add that. If we look down at our component here, we can see we have a couple of things in the state. The first thing is user, which can either be a string or null, and it's being initialized to null. And we also have an is logged in, which should just be a boolean. And then all we have besides that is just two functions. We have login, which sets the login state to true, and then logout, which just sets it to false. Pretty simple. Let's quickly make a type to represent all these things. Above the component here, which is our app component, I'm actually going to make a type. I'm going to call it type, we'll call it context type, for good reason that I'll show you in a second. And then we need to add a couple of things. Let's say we want the first thing, our user, to be one of the things. That'll just be a string. So we'll say user should be a string. We will say is logged in should be a boolean. And then we can do the login and logout functions. So for login, it would just look like this. We would do this. It takes in no arguments, so there'll be nothing here. And it doesn't return anything, so that'd be void. So we would do this. And the same could be said for logout. It would look the same. Just replace this with out right here. And now we have the four things that we're going to want to pass down through our context. So we're saying, okay, this app here is some parent component, right? We want to pass down these four things, that being user, is logged in, and then the login and logout functions. We want to pass down those four things to some child component without having to explicitly mention them in the props, especially if we have to go through multiple components, because that's just a hassle. Now, when we create our context, which I'll actually move below this just for the sake of readability, we can make this of type context type or null. Down here, the last thing we need to worry about is actually passing that down through our context. So how we would do that is by wrapping our whatever child component we had with the context.provider and then passing in the value as if it were a prop. So let's actually define the value that we're going to pass down. So we're going to go down here and we're just going to type in const value. And we know this should be of type context type. So let's just add that. And then let's just define an object with the four things. So it is going to be user, it is going to be login, it is going to be logout, and actually right here we'll add is logged in. And it looks like we're getting an error here saying, okay, so it could be string or null. So let's actually add that up here. Let's say it could be string or null, and now that error should go away. So this is the value that we actually want to pass down to potential child components. So let's actually pass that in here through our context provider. Now, if we were to have a child component, which I've just named child component, we could access this data right here by simply calling the useContext hook and passing in the name of the context that we created right up here. And so now context data would be equal to this object, and this is in, again, a child component. Before we do anything, when working with context, we'd probably want to check in this component here, this child component, whether this context is a null or not, since that's one of the possible types that we gave it. So we could do that by, let's say in our JSX, just writing context data, and we can do the conditional statement. So it's saying if only if context data is not null, then print it out. Or we could always do some checking like, something like if not context data or something like this, and just do some checking to make sure that it's not null. I hope this gives you a somewhat solid idea of how we should use TypeScript with context in React. Just to quickly summarize in case that was too much. So first things first, the most important thing is that you are creating the context type of whatever context you're using. In this case, our parent component wants to pass down these 4 things. User is logged in, login, and log out. So what we do is we make this type, and then we create the context outside of our parent component that just says create context, and it can be of that context type, or it could be null too. And then in your parent component, you would have the things you want to put in your value. In our case, it's 2 pieces of state, user and is logged in, and then these 2 functions here. And then we are just making the value equal to this, and it should be of context type that we defined up here, just to make sure everything goes smoothly. And then, as always with context, we pass it through that context.provider, and we can pass that value down. And in any child component to access it, we can just call the useContext hook, and then now that data is readily available. And with that, we're going to end this video here. There may be some super niche things that I didn't cover with this video, but this should have covered all major topics on how to use TypeScript with React. If you got this far and found the video helpful, I would greatly appreciate you liking and subscribing, as it helps tremendously to get my videos out to new viewers. Take care everyone, and I'll see you in a future video.